In this video, I will try to explain why a gear pair is a half joint as per our class. We will start with two rigid bodies in a plane and which are connected by a revolute joint. We have called this a full joint and said it's a one freedom joint because it allows only 1 degree of freedom with respect to the joint. And we said it rests 2 degrees of freedom. In order to get to this point, we said there is a rigid link which has 3 degrees of freedom in total in space, 2D space. And then there's a second link, which is also 3 degrees of freedom. So total degrees of freedom is 6, 3 plus 3, as they are not connected right now. The moment we bring them together and pin them with a joint here, what we say is this whole object as a body can, as a system, the two bodies as a system can be moved in this direction and in this direction. They can also be rotated while maintaining that orientation. So that's the angle. So these are 3 degrees of freedom which are still with the system. You can also relatively move these in the sense that there can be a smaller angle theta instead of a larger angle theta 1. Theta 2 not equal to theta 1 is a 4th degree of freedom. And that's it. You cannot move one, say link 1 relative to link 2 horizontally or vertically. You cannot separate them out because they are pinned at this joint. That's bringing the whole system to 4 degree of freedom from 6. So it arrests 2 degrees of freedom. It's a one freedom joint. So at this joint now, you can only describe this theta 2. So this is for a full joint. So we call these as full joints, the revolute pairs. If I can give another example of full joint, let me draw a slot and a slider. This is a 3-off. This is also a 3-off. I can move vertically, horizontally, and I can rotate this. Similarly, I can move vertically, I can move it horizontally, I can rotate this. But the moment I put this sliding part inside of the guide with clearance only as necessary to make it move, now I can lift, or I can take the pair, move it vertically, move the thing together horizontally, tilt the whole thing together at an angle and make it at a different orientation. But when it comes to the relative motion between these two, these are absolute motion of the two things as a rigid body. In terms of the relative motion, I can slide this in and out, but I cannot take this part. I cannot move this part in this manner because there is a blockage here. I can also not tilt this for the same reasons because it's going to get blocked here. So again, 2 degrees of freedom are arrested. This is a one freedom joint. The sliding joint is also a full joint. Then if we look at an example of a higher pair, let's first talk something about something like a cam pair. These are two individual bodies. When they are separated out, body 1 has 3 degrees of freedom. and body 2 has 3 degrees of freedom. When there is a joint, which is a cam joint or a contact at this point here, if we call that a cam joint, then this has 3 degrees of freedom as a system. The whole thing can move together like this. But the relative degrees of freedom, if you look at those, you can turn one with respect to the other while maintaining contact. That is a theta. Roll while maintaining contact. You can also, so the next position would perhaps be something like this. As it rolls. That's a possibility. And then I was afraid of that. Yeah. The second option is I can slide this along this line, and there's absolutely no restriction to that. That's slip. So I'm allowing motion along this perpendicular direction to the normal at the point of contact. Those are 2 degrees of freedom that are still there. So the only degree that got arrested is movement along the normal. So there's a normal at this point of contact. That normal has the movement along this normal relative to each other has been arrested. This cam cannot just go into the other. So body 1 cannot go into the second body. So that's how this is a higher pair half joint. Similarly, if I can take the example of the gears, I have a gear pair. We don't have to even consider all the teeth. When we discuss gears and gear trains, we will talk about what this profile is. But this profile exists for each of the gear teeth, and we can just consider one of these. And say that obviously three absolute degrees of freedom, the whole set together can be moved like this. This is a center, this is a center. We can make the center move around and then have the same gear contact. And this would be the 3 absolute degrees of freedom. But what are now arrested are similar to how we saw in the cam case. There's a motion arrested along this contact normal, but there is a possibility to slip this and still maintain a gear joint. Slip this along this, or freely roll one with respect to the other without moving the positions of these centers. So those are the 5 degrees of freedom which is still possible when two bodies are in gear contact. So there's roll and slip. This is what I had mentioned when we were talking about half joints, that there is roll and slip. In most cases, we'll see these two. And that's how this is a total of 5 degrees of freedom within the system. Remember, I have not grounded any of these bodies. These are just two independent bodies coming into contact using a gear contact. And so all of these 5 different degrees of freedom exist. And so if I was to hold one of these or hold both of them and start trying to turn. I'm only restricting the absolute 3 degrees of freedom, absolute ones. The relative ones of roll and slip still exist.